for the given vectors, which don't have names. Show algebraically they are equivalent. Anytime in math they say show, that means it is true. You should be able to show that they are the same. If they said determine, that means it may or may not be true. So, fun things there. Oh, darn. I just realized I didn't label some points here. All right, to be clear, this top vector, we'll call this vector u. Oh, that's not supposed to be a triangle. What's going on here? This initial point is -2, -1/2. Good thing we're going slow this week. I don't know. I don't think it's the last time. And this one is 3, comma. Well, if I did a fraction there, I'll do a fraction here. 5/2. That's a 2 there, kids. What I wanted you to do is think about how do we figure out how long this is. All right, let's use the distance formula. Remember the notation used was the absolute value. Oh my gosh. Was the absolute value symbol. How do you find the distance between 2 points? What's the formula? Remember, your distance formula is just an application of your Pythagorean theorem. It doesn't matter which change you do first, just that you have to add in between. So we should have 3 minus -2. I'll clean that up in a second. Squared plus, let me change the batteries in here. And then 5/2. No, you said minus. Minus -1/2 squared. Ah. Good. That's nice. Good thing I'm not a perfectionist. There you go. What is the square root of 3 minus -2 quantity squared? Plus 5/2 minus -1/2 quantity squared. Oh, bam! That's a 4, everyone. Square root of 34. Good enough. All right, so that's its distance. How do we figure out its direction? You could do it in terms of an angle, or since it's sort of linear, we can do a slope instead. So we're going to call that m sub vector u. What's the formula for slope? Yep. So in this case, 5/2 minus -1/2. I don't think it was the battery. All over 3 minus -2. No. Oh, that's supposed to be -2, right? What is 5/2 minus -1/2? 3 over 3 minus -2. So your slope is 3/5. If you would, please Find the slope and magnitude of the other vector as I try to close more programs. All right, so what's the setup for the magnitude of, we'll call this vector v. Anyone? So square root of the quantity -2 minus -5, then what? Squared plus, oh, you did the y's first. That's fine. Okay, those are the difference of the y's. Now I have to do the difference of the x's. 0, 2, squared. Oh, I don't know if I'm going to make it. What is -2 minus -5? Squared. Plus 0 minus -5? Squared. 9 plus 25 underneath the square root. Square root of 34. Good. I think I know what happened. There's a lag in the response from students, and I think it affected the pen as well. Good. All right, so let's find the slope of vector v. This one will be a little bit easier because there's no fractions. So change in y, what's it going to be? -5 minus -2, change in y. Yeah, because that's just 0 there. Over -5 minus 0. What do we got? 3/5. Yep. All right, very good. There is another way of determining if two vectors are equivalent without having to use the slope and the y-intercept, but the slope and the distance formula, but we don't learn what that is until the next section. It goes a lot faster, and really all it turns out to do is subtraction, but we'll learn that next. Questions on showing two vectors are equivalent. All right, the symbol we would use to show that two vectors are equivalent is, surprisingly, the equal sign. So nothing too crazy there.